Hi, so today we're going to be looking at the Chapter 4 Notepage, and the topic is factoring and solving triangles using trigonometry. So question number 1 on page 1, they want you to factor the trinomial x squared plus 10x plus 16. So when you're factoring, you want to use these four tools to help you. So always look for a GCF. GCF stands for greatest common factor. And then you're going to look for perfect square patterns. And then if it doesn't fit the pattern, then you're going to try some easy factoring. And then beyond that, you're going to go to something called master product. So for number 1, we have x squared plus 10x plus 16. And I don't see a greatest common factor, but I do see a perfect square here. X squared is a perfect square, and 16 is a perfect square. But it does not fit a perfect square pattern because the square root of 16 is 4, and if you double 4, you get 8, not 10. Okay, so it's close, but not quite. So we're going to see if we can use some easy factoring on it. So you see what multiplies to get 16 and adds to get 10. So if you try 2 times 8 is where you get the 16. And if you do 2x for the inside and 8x for the outside, that's what you would use to get your 10x. Okay? Jumping over to problem number 2. This one, we have the boxes. So to get this box x squared, we multiply an x times an x. And to get this box over here, we multiply a 3 and an x to get this 3x. For this box right here, we would multiply a 5 and an x to get 5x. And for the last box, we would multiply a 5 and a 3 to get 15. Okay? So that when you factor, you will get the, across the top, you'll get the x plus 3. And when you multiply down the side, you will get the x plus 5. All right, for question number 3, I found a greatest common factor because a factor of 8x and 6 is 2, so I pulled out a 2. And that leaves me with 4x plus 3, and I can't factor that one anymore, so we're done with number 3. That one's quick. All right, problem number 4, we have 9x squared minus 36, and I found the GCF of 9, so I pulled out a 9. And inside the parentheses, that leaves me with x squared minus 4. And then that x squared minus 4 actually follows one of the perfect square factors, or perfect square polynomials, because this is an x squared and this is a 4, and they're being subtracted. That means you're going to have opposite signs here, and it doesn't matter which one goes first, so one's a plus, one's a minus. Square root of x squared is x and x, and the square root of 4 is 2 and 2. The inside and the outside are going to cancel that middle term. That's why it's only 2 terms instead of 3-term polynomial. So it's a binomial instead of a trinomial. All right, jumping down to question number 5, we have x squared minus 9x minus 2. There's no GCF, and 22 is definitely not a perfect square. So we're going to use easy factoring on this one. And so you have to look and see what's going to multiply to get negative 22, and add or subtract to get negative 9x. And the only factors I could think of were 11 and 22. And so to decide which one was negative and which one was positive, I looked to the middle term and saw that it's negative. So I know that the negative 11, or the negative sign, needs to go with the 11. So the inside would be negative 11x, and the outside would be plus 2x. If you combine those two, you're going to get the negative 9x. And a negative 11 times a 22 gives you a negative 22. So one's got to be negative, and one has to be positive. All right. Question number 6, we have 2x squared plus 12x plus 16. I definitely see a greatest common factor because these are all even, right? And the leading coefficient is a 2. So whatever your leading coefficient is, always check and see if that's a factor of all 3 terms. And it definitely is. So you're going to pull out the 2. That leaves you with x squared plus 6x plus 8. 8 is not a perfect square factor, so I'm going to use easy factoring. What multiplies to get 8? And adds to get 6. So in this case, it's 2 and 4. 2 times 4 gets you the 8. The inside is the 2x. The outside is the 4x. The 2x plus the 4x is the 6x. All right.